Maximum difference scaling, MaxDiff, is also known as best-worst scaling. And this presentation is going to introduce you to this technique and show how Sawtooth Software's MaxDiff program can help you easily and quickly design these kinds of studies and field them and analyze the data. In market research, our common task is to measure items. We're commonly asked to measure brands, products, services, features, advertisements, political candidates, positions, all sorts of things. We want to learn importance, preference, and typically what we do is the ubiquitous monadic rating scale. That fancy word means essentially a grid, a rating scale where we show the items and we ask people to rate it on, say, a 1 to 5 point scale or a 0 to 10 point scale. Now, the common problems with this is that the rating scale leads to a lack of discrimination among the items, some scale use bias because people use scales differently, especially there are a lot of differences across cultures. Also, it's difficult for some respondents to understand how to use rating scales, which causes some problems for some respondents. So possible solutions that have been recommended over the years are to do a ranking exercise to ask respondents to sort them from best to worst, but this can become impractical with more than about 7 items. Other possibilities include the constant sum allocation, where a respondent would allocate, say, 100 points across all the items. But this can become difficult also when you have more than about 7 items. And respondents may not allocate all the chips independently. And making the answer sum to a particular value can be distracting for some respondents. So a very old technique that's been proposed that actually works really well is the method of paired comparisons, where you just show 2 items to a respondent, whether they be attributes or brands or political candidates, and you say, which do you prefer, A or B? And you repeat that for a number of comparisons, A versus C, B versus D, etc. For example, if we were studying restaurant attributes, we could ask the respondent, which is more important to you in a restaurant, a clean eating area or that the food tastes wonderful? Now, the neat thing about this is that although we're asking for a crude response, left or right, A or B, we can get a lot of gold out of that dross. We get preference importance scores using a series of simple paired comparisons, and we can derive the scores that we need by observing trade-offs rather than asking respondents to directly declare those scores. Because we're using a forced trade-off between A versus B, etc., this leads to greater discrimination and more information, it turns out. And it's simple. Even a small child could understand the task. Now then, we're to the point that we wanted to talk about, which is the maximum difference scaling or best-worst scaling. It turns out that MaxDiff is just a more efficient way to collect paired comparisons information. For example, this is a maximum difference or best-worst task. Here we're showing 4 attributes about a fast food restaurant. And we're asking respondents to indicate which of these would make them most likely want to visit a restaurant versus least likely. And this particular respondent has said that your order is always completed correctly, or item A is most likely to make them want to visit a restaurant, and that the food tastes wonderful is least likely to influence them to go to a restaurant. It turns out that if the respondent answers in this way, A is best and D is worst, we actually learn about 5 of the 6 possible paired comparisons among those 4 items. We learn that A is greater than B, A is greater than C and D. We learn that B is greater than D and C is greater than D. The only thing we don't learn about is the relationship between B and C. So, to summarize, relative to the standard rating scales, paired comparisons, and especially the sophisticated extension best-worst, they're free from scale use bias, they force trade-offs of items, they're better for audiences that might not understand well how to use a rating scale, and they provide, importantly, better discrimination among the items and between groups of people on the items. So let's talk about how to set up a simple study in Sawtooth Software's SSI web program that can run maximum difference projects. We've got 10 attributes related to fast food restaurants, and I've gone ahead and put these into a Microsoft Word document as well as the prologue that you might say at the top of the question. Typically, you'll have your surveys developed in such a thing. Now we can go over to the SSI web system by Sawtooth Software, and we can open up the questions area, And at this point, we only have a small questionnaire. I've included a particular question in here, which is, how often do you visit fast food restaurants? But I could include other questions as well. After that question, I'm going to insert a page break, and I'm going to add a MaxDiff study. And we'll call this particular MaxDiff study food. The first thing that it asks me to do is input the text that I want to show above and below this particular question. So I can go over to my Microsoft Word document, and I can take the text, and I can go back here and paste it in, and I can go back and grab the text for the second part, and I can put that there. And my label text currently says most important and least important, and I want that to say most likely and least likely. Once I've got that, I've just got to paste in my items. I go back to Microsoft Word, I highlight my 10 items, I copy them, and I click the paste list members from the clipboard, and it pastes them in. The software asks me the format that I want to use, whether I want to include the best column on the left and the worst on the right, and I think I'm going to choose Style 2, which shows the best and the worst right next to one another. We can preview this, except for we can't preview it yet because I have to set up the design. I need to say how many items we're going to show per set, in this case 4, and how many sets that I want to show to people, how many tasks. In this case, I'm going to choose to show respondents 8 particular tasks because that will give us about enough information to be able to estimate good individual scores. The next step is to generate the experimental design, and the software makes 1,000 separate attempts at this and picks the one best out of the 1,000. It's going to try to balance how often each item appears in the experiment. It wants to show each item an equal number of times and how often each item appears with every other item so that we can estimate good scores. That's called a balanced and orthogonal experiment. Once I've got that, I can preview what I've got to this point, and we can see that this is what the question looks like. I could modify the colors and change things around a little bit if I'd like. But that's the basic setup, and once I return to the questionnaire, you'll see that the software has automatically installed all 8 of those MaxDiff questions in the questionnaire list. I can test this questionnaire by clicking here, test, and test the survey locally, and it's going to fire it up locally on my laptop in a browser, just like respondents would see it when I eventually put it on the internet. At this point, I've just got a welcome screen. I have a simple select question which asks how often I visit fast food restaurants. And then my MaxDiff questions start, and the respondent is going to answer most likely and least likely all the way through for 8 questions, etc. Eventually, I'll have interviewed a bunch of people, and then I'm going to want to analyze their data. All I have to do to analyze the data is to click on Analysis and compute the scores. The software uses a technique called hierarchical Bayesian estimation to estimate the scores. Although that's a fancy word for the estimation technique, in the end, the scores are really simple. All they are positive values that sum to 100. And it's very simple to present that kind of data to managers or other analysts because it is ratio scaled data where a 10 is twice as important or twice as preferred as a 5, and they sum to 100. We can plot them as bar charts. The software summarizes the scores for me right here and gives me 95% confidence intervals. It also will show me the scores for each respondent. In this case, I only have 3 respondents in my data set. I get a fit statistic showing me whether the respondents did a very good job or not. My second and third respondents actually were a little bit sloppy. And then it gives me the scores for each of the 10 items, and these scores sum to 100. It's very simple to be able to take those scores and just to produce a chart, such as a bar chart, or we can submit them to cluster analysis for finding segments. or to turf analysis for optimizing the right bundle of items. There's so many things you can do with MaxDiff data, and it's much more powerful and better than the rating scale.